Chapter 1, Lesson 3, Part 1, we'll be focusing on common factors. Vocabulary. A factor is a whole number that can be multiplied to be another whole number. A factor will never be larger than the original number. A common factor are factors that two or more whole numbers share. The greatest common factor, which you will see abbreviated as GCF, is the common factor of a pair of numbers that has the highest value. To find common factors. To find common factors of a number, you need to know your multiplication facts. So to find the factors of 18, you're simply listing the multiplication facts that equal 18. 1 times 18 is 18, 2 times 9, and 3 times 6. So all 6 of these numbers here are factors of 18. 1, 2, 3, 6, 9, and 18. Same thing for 32. 1 times 32, 2 times 16, and 4 times 8 are the factors. So the factors of 32 are 1, 2, 4, 8, 16, and 32. To find the common factors, we look for the numbers of factors that 18 and 32 have in common. So they're circled here for us. Both of them have a common factor of 1. Here's a big hint. Every set of numbers will have a common factor of 1 and 2. These two numbers don't have any other factors in common. So let's practice between 24 and 16. This is number 3 in your 1.3 reteach packet. So they gave us 1 and 24. So I know 2 times 12. I also know 3 times 8 and 4 times 6. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. You see I kind of went down the left side and then up the right side to get all of those numbers. Now 60, of course, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. I'm going to list those as well. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60 is already listed. So I'm going to go through and circle any that I see both numbers have. Like I said, 1 will always be in common. 2, 3, 4, 6. They don't have to be right on top of each other to be common. 12 is common in both numbers. And that looks like that's it. So I'll list them here. 1 is already given. 2, 3, 4, 6. Looks like I'm missing one. 1, 2, 3, 4, 6, and 12. I think they just gave us an extra spot here, so we'll cross that out. So finding the greatest common factor, we're just going to be looking for the common factors of two numbers and then identifying the one with the highest value. So we did 12 and 18. The factors are 1, 2, 3, and 6. And then for 18, 1, 2, 3, 6. So the greatest number out of those 4, of course, is 4. So the greatest common factor of 12 and 18 is 6. So let's try that with 40 and 75. Let's find the greatest common factor. So first we're going to find all factors of 40. 1 times 40, 2 times 20, 4 times 10, and 5 times 8. So list those in order. It is helpful if we list them in numerical order. 1, 2, 4, 5, 8, 10, 20, and 40. Now 75, 1 and 75, 3 and 25, and 5 and 15. So I'll list those factors as well. 1, 3, 5, 15, 25, and 75. So I'm going to go ahead and in a different color here, circle common factors. 1, no 2 here, no 4. I have a 5 in both of my columns. 8, looks like 1 and 5 are my only common factors. So which is larger? 5, of course. The greatest common factor is 5. There is another method to find greatest common factor. It's not as popular and can sometimes be confusing, but if you like this method, feel free to use it. We're using the factor trees that we learned about in the last session. So we're breaking down 12 and we're breaking down 18 into their prime factors. So 12 and 18, both 12's prime factors are 2 times 2 times 3, and 18's are 2 times 3 times 3. So what they did is circled the ones that they have in common and they can't repeat. So here we have a 2 in 18 and here's another 2, a 2 in 12 and a 2 in 18. And then a 3 in 12 and a 3 in 18. They can only match up once. We can't double those up. So then we multiply those common factors 2 times 3 to find that the greatest common factor is 6. Again, I think this one's slightly more complicated, but if you like this method, go ahead and use it. We will attempt this method and break down 48 into, let's see, 2 and 24. I know our factors, 2 and 12, 2 and 6, and then 2 and 3. So the factors of 48 are 2 times 2. I forgot to circle them. Times 2 times 2 times 3. And now let's do the same with 64. 64 is 2 and 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. So 64 is 2 times 2 times 2 times 2 times 2 times 2. So I'm going to start matching those numbers up. This 2 and this 2 can match 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 up. I have a 3 in 48, but not in 64, so I can't use that. And I don't have any more 2's up in 48, so I can't use that either. So now I break that down into 2 times 2 times 2 times 2. And I do my math. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the greatest common factor of 48 and 64 is 16. There is another method too. It's that repeated division method, except we're putting both numbers on the same line, 12 and 18 on the same line. We're going to divide by the least common prime factor of both, which in this case is 2. 12 divided by 2 is 6. 18 divided by 2 is 9. Now the least common factor of both of these is 3. So we have 6 divided by 3 is 2, and 9 divided by 3 is 3. Since we don't have any more prime factors besides 1 that are in common, we're done at this point. So we use the prime factors we divided by to find the greatest common factor. So let's try this with 48 and 64. I know we already know the answer, but it's good practice to keep going. They already started with the 2. And again, we're dividing by 2. So 24 divided by 2 is 12. 32 divided by 2 is 16. So I know that 12 and 16 can still be divided by 2. So I'm going to do that again. 6 and 8. Again, each of these can be divided by 2, but now I have a 3 and a 4. Since 3 and 4 can't be divided by the same prime factor, we're done. So again, we have 2 times 2 times 2 times 2. which equals 16. We can use the greatest common factor of two numbers for the distributive property to break up two numbers, an addition problem like 36 and 42, to separate that out. So first, you would need to find the greatest common factor of 36 and 42 using whichever method you choose. This one happens to be 6. So now the 6 that you found is going to be on the outside of the parentheses. You're going to divide each of these numbers by 6. Divide by 6. So 36 divided by 6 equals 6, and 42 divided by 6 equals 7. So that's now what will go on the inside of your parentheses after your division problem. This is not something that I'll be asking you to do a lot of, but it is something I would like to introduce you to at this point. So let's try using the distributive property with 16 and 40. I'm going to use my factor tree to break 16 down. 2, 2 and 8. 8 is 4 and 2. And here we have 2 and 2. So 16 is 2 times 2 times 2 times 2. And now let's try 40. I have 2 and 20. Then I have 10 and 2. And 5 and 2, which are both prime numbers. Just fix that so we can be clear. So 2 times 2 times 2 times 5. So the greatest common factor of 16 and 40, of course, we're going to match up those numbers. So 2 and 2, 2 and 2, 2 and 2. So is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. The greatest common factor of 16 and 40 is 8. So now if this was an addition problem, I could pull that out into 8 times what equals 16? 2, of course. And 8 times 5 equals 40. So I'm going to put those two numbers inside my parentheses with the plus signs, and my greatest common factor can stay on the outside. Again, this is not something you'll be asked to do a lot of, but knowing how to distribute a number throughout is going to be useful in the future.